Hi everybody, welcome to the third video on surds, and in this one we're looking at adding and subtracting surds. Now when we're adding and subtracting surds, we can't just add them left, right and centre, they need to be the same. So for that example, if we're thinking about the theory, we could only add or subtract, this wee symbol in the centre just means add or subtract ones that are the same. So if they're not the same, we can't add them. An example of that is if we had, say, root 3, add root 3, well, we've just got two lots of root 3. Similarly, if we had 3 lots of root 2 and we subtracted 2 lots of root 2, we would get 1 lot of root 2. So the key here is that we need to make sure that they are the same surd underneath. Sorry, nearly missed the answer there. Now, what if they're different? Well, if they're different, we can't add them. But sometimes we can simplify them down and then add them. So a good example of this is if we have the square root of 18, add 2 lots of root 2. Now, we can't put root 18 and root 2 together, so don't. Some people would actually think it'd end up being 2 root 20, where it's not. This root 18 we have to simplify down first of all, and we do that using our simplifying technique that we looked at in the previous video. So root 18 goes down to 9 times 2, because 9 is the largest perfect square that goes into 18, and we still got that 2 root 2 over there. Break them apart. Root 9 times root 2, add 2 root 2, so we get 3 root 2, add 2 root 2. Now we can add them because they're both in a form that is similar to one another. So in this case, this answer is going to be 5 root 2. So we need to make sure that they are the same underneath the root. Another example we could have the root of 50. Subtract the root of 32. Now, in this case, both of them we have to simplify down. So remember your perfect squares: 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and so on. So the largest perfect square that makes 50 is 25. So we can break that down to 25 times 2, subtract, and the largest that makes 32 is 16. So 16 times 2. Now you'll know you're on the right direction if both the surds have a similar number underneath them. In this case it's 2. So we can break them apart to root 25 times root 2, subtract root 16 times root 2. We can solve root 25 to be 5. Root 2 just stays as root 2. Root 16, we can simplify that and we know that the square root of 16 is 4. And 2, well, root 2 is just going to stay the same. Now we can subtract them because we've got them both in a form where they're the same. So 5 lots of root 2, subtract 4 lots of root 2, just leave us with 1 lot of root 2. Now, a more complex example that we can think of is, say, for the likes of 2 root 48 plus 3 root 12. And once again, we have to first break them down into their simplified surds. So in this case, we want to break down 48. So using our perfect squares, 25, 36, 49, 64, 81, 100, 121, 144, and etc. goes up. So The largest number that we can make 48 with using as a product is a perfect square is 16. So we get 2 times 16 times 3 under the root. Add 3, and the largest perfect square that makes 12 is going to be 4. So 4 times 3. And we know we're on the right track here because we've got a 3 and a 3 both underneath it. And then it's just a simple case of breaking them apart. So 2 times root 16 times root 3. Add 3 times root 4 times root 3. 2 is not going to change. Root 16, we know the square root of 16 is 4. And we've got root 3. Now for the second one. 3 is not going to change. The square root of 4, we know that that's 2. And the root of 3 we don't know, so we'll just leave as the square root of 3. Bringing our numbers together, 2 times 4 gives us 8. Root 3 stays as root 3. Add 3 times 2 gives us 6. Root 3 stays as root 3. And now we can add them together because 8 lots of root 3 add 6 lots of root 3 gives us 14 lots of root 3. Now the thing to remember in this case is if you can simplify it down beforehand, you need to do that because you can't add two different surds. So in this case we couldn't add root 48 and root 12 because they're too different. You know you're on the right track with simplifying if you've got two numbers the same underneath that aren't the perfect squares, and then it's just a case of breaking it down, bringing everything together slowly bit by bit to get to your final answer.